3. Topic is alkyl halide. Contents are kinetics, reaction mechanism, order of reactivity of alkyl halide and stereochemistry. Let us start. What are the reactions? Reactions are of two types, ionic reaction and radical reaction. So what is the ionic reaction? Ionic reactions are those where bond breaking and bond making takes place in a heterolytic fashion. For example, this that is Rx. Rx means alkyl halide. In this case, the covalent bond is break in such a way that there is a previously bonded species takes both original electrons from the other species, and hence there is a formation of the positive and negative charges. Then radical reactions. Then radical reactions means what? The bond breaking and bond making takes place in a homolytic fashion. Homolytic fashion means the breaking of a covalent bond in such a way that each fragment takes away the one of the shared electrons, okay, and hence there is a formation of the radical ion. Okay, understood? Okay. Next, substitution reaction, that is nucleophilic substitution. So what do you mean by the nucleophilic substitution reaction? Okay, so substitution means what? The replacement of atom or group of atoms in a compound by another atom or group of atoms. Then nucleophilic. Nucleophilic means it is derived from the nucleus, which is a positive charge, and philic means what? The affinity for the positive charge. Hence nucleophilic means these are the electron rich atoms, and hence they have the affinity towards the positive charge. Okay, then unimolecular. Then unimolecular means what? The reaction involving only one molecule in the transition state of rate limiting state. Okay, so this is the example of nucleophilic substitution reaction, where Y is the nucleophile which attack the alkyl halide and there is a formation of the product. Okay, so reaction may be the aliphatic or aromatic. Okay, understood? Next, kinetics of the reaction. Okay, so the rate of reaction depends upon the concentration of the only one reactant, that is the alkyl halide. Okay, so the concentration of the alkyl halide if change, that is doubles, then there is a rate of reaction will be double, and changing of the nucleophile does not affect the rate of reaction. Okay, so rate of reaction that only depends upon the concentration of the only one reactant, that is the alkyl halide. Okay, next, reaction mechanism. So in the first step, the carbon halogen bond breaks and previously shared pair electrons stays with the halogen atom. Okay, and as a result there is a formation of the carbocation. Okay, in the second step, the nucleophile, that is this is the nucleophile H2O that rapidly reacts with the carbocation and to form the protonated alcohol. Okay, so this is the protonated alcohol, means it is in a acidic form. Then this protonated alcohol that may be converted into the alcohol, that is the basic form, but it is depends upon the pH of the solvent, that is depends upon the solvent means H2O. Okay, understood? Then why the tertiary alkyl halides undergo SN1 reaction? Because the tertiary carbocations are more stable than the primary and the secondary. Next, the energy diagram for SN1 reaction. In SN1 reaction, the activation energy for step 1 is highest because it is very critical to break the single molecule, and hence this step 1 is the slowest step. It is also called as the rate determining state. But once the carbocation is formed, the nucleophile immediately reacts with the carbocation, and hence the step is fast. Okay, and this carbocation is at a lower energy level as compared to the transition state. Why? Because transition state at a higher energy level, and there is the formation of the bond and breaking of bond is not completed. Okay, and so it is very higher level. Okay, understood? Next, order of reactivity. The order of reactivity of SN1 reactions depends on the stability of the carbocation intermediate that is formed during the nucleophilic substitution reaction. And so the pi bonds and bulky alkyl groups that increases the stability of the carbocation. Why? Because these bulky alkyl groups are the electron releasing groups, and hence this carbocation, that is the electron deficient carbocation, and hence it stables the molecule. So the order of reactivity of the SN1 reaction is as it is, that is the tertiary is more stable than the secondary, and then the primary carbocation, and then that of the methyl group. Okay, understood? Next, stereochemistry. In the first step, that is carbocation is formed, is planar. Planar means what? These three bonds connected to the carbocation is in a single plane, and hence attack of the nucleophile from either of the side to the carbocation gives the racemic product. Okay, but complete racemization doesn't take place. This is because the nucleophile that attacks the carbocation, this nucleophile that attacks the carbocation even before the departing halide ion has been sufficiently moved away from the carbocation. Okay, and the negatively charged halide ion shields the carbocation. Shields means what? Protect the carbocation from being attacked on the front side. Okay, and hence the back side attack that leads to the inversion of the configuration. Okay, so thus the actual product that is get is a mixture of the enantiomers. Okay, and what are the racemic mixture? Racemic mixture means what? The equal quantities of two enantiomers are substances that have the mirror images of one another but not superimposable. Okay, so there is a formation of the one product that is the inverted configuration, and other product that is the retained configuration. Okay, so this is the mixture of the enantiomers, but the maximum proportion of the product is the inverted configuration. Okay, and so it is about the 50 to 70% that the product we will get with the inverted configuration. Okay, so in next video lecture we will see the rearrangement of carbocation and also the factors affecting the SN1 reaction. Okay, understood? Thank you.